Did you know that coffee is being used to power ocean-going ships? Well, not the actual coffee itself, but this stuff, the coffee grounds, the waste. It's used to make bio-LNG, a fuel that can help decarbonise shipping. So there you go, something to think about next time you sip on your latte. I'm Dallas Campbell, science reporter and journalist. I'll be looking at how agricultural waste, manure, food waste, and yes, even spent coffee grounds are being transformed by Shell in Denmark into biomethane, a renewable fuel that, when liquefied into bio-LNG, can play an increasingly important role for shipping. The number of LNG-fueled vessels in operation globally is increasing as fleets aim to decarbonise. And if you can make that LNG out of food waste or agricultural waste, then suddenly you've got bio-LNG, a renewable alternative that can significantly reduce emissions, helping shipping companies to achieve their climate ambitions. This is something that companies like Hapag Lloyd, one of the world's largest fleets, is already taking advantage of by blending in bio-LNG, or liquefied biomethane, to help meet their decarbonisation targets. This also benefits their customers, reducing the carbon footprint tied to the transportation of goods we all use every day.
The shipping sector consumes more than 250 million tons of fuels. And if we want to decarbonize whole shipping sector, we need large amount of biofuel. Right now, we are relying on biofuels for the decarbonization of our existing fleet, which run on single fuel engines. But we are also now moving towards biomethane for our dual fuel LNG vessels. And I think biomethane will play a very significant role in decarbonizing LNG fleet.
And it's not just emissions reduction that is driving this shift. Feedstock for liquid biofuels such as vegetable oils and animal fats are in limited supply.
For biomethane, we can rely on organic waste feedstocks, which are available in good quantities as compared to the feedstocks for liquid biofuels, which have a very restricted quantity available.
One of the more abundant feedstocks for making biomethane is agricultural waste. It's the reason Shell is now working with over 700 farmers here in Denmark. At this farm, 1,500 cows produce around 1,000 tons of manure per week.
5 days a week, they come to pick up manure here and bring it to the biogas plant in Holsted.
But you get something back from it as well.
Yeah, we get the manure back when they have taken the gas.
And is that manure better than the kind of raw manure that you started with?
It's much better for the plant.
In fact, the whole process has advantages, not just for the crops, the farmers and the local economy, but for the environment too. So not so long ago, raw cow manure would just be spread as it is all over the fields as a fertiliser. But of course, it would give off methane, which is a really potent greenhouse gas. Now it's taken to the gas plant, that methane is taken off, purified into biomethane, and the waste product that the farmer gets back, called digestate, is a really high-quality organic fertiliser. This helps farmers reduce cost and emissions compared to using synthetic fertilisers. It's a win-win. And there is more good news. Bio-LNG made from manure can achieve negative carbon intensity values, because the capturing of methane from manure counts towards avoided emissions in European Union regulations. To find out more, I've come to the nearby Korskro biogas plant. It's just one of 13 owned and operated by Shell in Denmark. It's absolutely amazing, the scale of it. It's like a giant industrial digestion system. And these are the stomachs. And inside these giant stomachs, it's warm, heated to 50 degrees Celsius to create the perfect environment for bacteria to thrive and break down the bio-waste. As that happens, gas is produced. That gas is then filtered, removing CO2 and impurities, so the remaining biomethane can then be injected directly into the Danish gas grid.
Almost 40% of the gas in the Danish gas grid is produced at places like this one. You can use it just for heating houses in the neighborhood, but you can also take it out, liquefied. You can even have a ship running on the bio-LNG.
Why is this important, do you think? I mean, where does it kind of fit into the big picture?
It fits in because it's taking the waste that we already have. Instead of putting it just in landfills or whatever, we can use it and we can reduce emissions from it.
It's the ultimate in recycling, isn't it?
It's the ultimate recycling. Yes, exactly.
And this is what makes bio-LNG so attractive, because it's a circular fuel. The carbon it contains circulates within the environment. In the laboratory, Shell scientists are refining the production process. Today, they're mixing grated straw, potato starch, pig and cow manure, and coffee grounds, testing which blend of feedstock produces the most gas, giving the highest production efficiency. All that biomethane comes down to this pipe here, and because it's chemically very similar to natural gas, it can go straight into the Danish gas system right below my feet. Once liquefied, it can be supplied as bio-LNG to power ships wherever it's needed. So how do I know I've actually bought bio-LNG as opposed to regular LNG? Well, we use a certification system called mass balancing, and to demonstrate, we've got an analogy here. The orange juice on the right represents ordinary LNG. The bottle on the left is bio-LNG, and I know that because my receipt tells me everything about the product that I bought, including the quality and the quantity. In the grid, bio-LNG and ordinary LNG are mixed. So obviously they can't be separated now, but I can transport them all the way over here through the gas pipeline, liquefy it, and put it in my shipping fleet ready to be used. How do I know that I've used bio-LNG in here? Because I've got my certificate to prove it. This guarantees that the bio-LNG I bought is sold only to me. A key strength of mass balancing is delivering renewable fuels through widely developed infrastructure, meaning it's more cost-effective, efficient, and investments can focus on scaling up production. And as of 2025, Shell has more than 20 bunkering locations across Europe and the US offering bio-LNG. But regulation still needs to be widely adopted.
I think mass balancing is very important for success of biomethane. So that system is like right now it's operational within EU only. But for example, in United States, there is also grid, but that grid is not certified yet for EU regulations.
If you could wave a magic wand, how would you solve the regulatory issue?
So we are expecting that International Maritime Organization will streamline all the rules across the globe, where we should be able to use mass balancing and we should be able to use maximum benefit which biomethane provides us because of its avoided emissions and negative carbon intensity potential.
What's the appeal for the customers?
So our customers, like cargo owners, they are big brands, so they have their Scope 3 emission reduction targets. And in order to achieve those targets, they rely on us that the container services we provide to them should run on biomethane. It gives them brand strength, it helps us achieve our decarbonization goals, so it's a win-win.